Hello all, welcome to Excel Academy. So today we have some small revision class and we are going to do one IDFT problem, right, on 4-point DFT. So why a revision class is because I'm just brushing up what we discussed till now with respect to 4-point DFT. A small brief small revision class we are doing that. So please do try to watch this video without fail because this video is very important. And one more thing to tell us that we have discussed with respect to the question paper. We saw that there is a question only, more and more questions based on 4-point DFT, and 8-point DFTs are very rare that you see in your question paper. Why I am showcasing you only 18/52 question paper is because that question paper is only based on a syllabus, right? Whatever the syllabus you have, that the same syllabus 18/52 students, that is 18 scheme students had. So that is why you have to refer 18/52 syllabus so that you won't get confused. In that you can see that 8-point DFTs are really less questions, right? So that is why you have to work more and more on 4-point DFT. That too, we worked on very first method called as what? That is your matrix method, right? Yes, your matrix method. Why I am going like this is because it's for your use, right? So you don't want to struggle during the time of exam. So that is why I'm making you ready for your exams right from now itself, right? Yes. What is the matter is that if you just blindly study, then it would be like something when you go for your exams, then you would like, I have blindly studied this question had come for exams, I would have studied this, I would have studied that, and if you feel, then it is really a waste. That is why I suggest you to study for the examination from the examination point of view. That means that you have to just take the question paper, your syllabus, and what I can say the this one, which one, that is the a textbook, and first you need to see the first topic from the syllabus, then check with the question paper. After you check with the question paper, so what is supposed to do is that, so you need to make sure that that particular topic has been come in the question paper. What you have to do, take the syllabus, check with the syllabus, check with the very first topic of the syllabus, check with the question paper, and you need to make sure that the very first topic from the syllabus has come in the question, has appeared in the question paper. That too for how many marks. If it is repeated, you can put it as star. If it is completely repeated in all the question paper, it's a super important question, and you're supposed to practice that more and more without fail. If you do like that only, you get to know, because for each and every subject that has been prescribed by VTU, it is the only mantra you have to do. You have to work on for your exams itself first, and then the understanding level, right? Understanding, if you understand everything, it is not a matter, but for your exams you have to only work for the question papers and your syllabus and your textbook, right? Your question papers matter a lot because you get to know how the question comes for your exams, and then you get to know what are the questions that is coming for exams, and how many marks for that particular question, right? Because it is like for many people question paper is a success mantra. So that is why I suggest you to have a question paper from the beginning of the, from the day one of your studies, right? If your fourth semester had been started now and you have started with all the subjects, and from the day one your question paper is the success mantra for your examinations. You get to know how the questions come, and you can easily get more marks, right? And you can easily get more marks, right? That is what is my what I can say, the success mantra for an exam for each and every subject that has been prescribed by VTU, right? Yes. That is why I always open the question paper and showcase to you, so that you get to know how the question comes and how you have to work for your exams, right? Yes. And this is matrix method, wherein we had DFT formula for matrix method, which has been given by what? It has been given by, that is equal to your x of 4 into, just a minute, I'm going to write the formula. So it is x of n is equal to, x of n is equal to yes, okay, correct, yes. So now here what you're supposed to do is to send the number of samples, and it might be 4 5 or 8, right? Like any no, values of DFT. Either it might be 4, here also the same, here also the same. Either it might be any point DFT, that is your 4, here what I can say 5 point DFT or a 6 point DFT or 8 point DFT, it is like that. Right? If you consider the IDFT formula, it is what is my x of what I can say the k, right? Just a minute, I'm going to write the formula. So sorry, just a minute, students. Yes, uh, this is all for your benefit, and please try to make use of this without fail. Okay. So why I am telling you to make use of it without fail is because we are only working for exams, and I suggest you to follow these videos without fail. Working for exams in the sense like we are not only considering the important topics that comes for exam, we are also considering all other concepts that also that also is present in the syllabus, and we are also going to do that. We are not leaving that, but I am going to work on the examination process. That is in the sense I am going to see all the important questions that comes for exam. According to that only I am going to work it on with respect to this particular subject as well as circuit and control, so that it would be helpful for you, right? And in the meanwhile I am not going to leave any of the concept from the syllabus, please to remember, right? Yes. So we are not working in an order, but we are trying to work out in the examination manner. The one which is really important for exam, we are going to do first. Then we come to what I can say the topics which is not of that much importance, and wherein you have to just practice for the sake of exams. In the sense, if you might give answer, you have to make an assumption and you have to just practice it, nothing else. Okay. Yes. So this is what is my IDFT formula, wherein my small x of 4 is equal to 1 by 4 into what I can say the omega of 4, that is into what I can say omega of 4 star, that is into x of 4. Omega of 4 star in the sense that is equal to, here I have taken the 4-point DFT formula. So here you can just write it as n, right? You can just write it as what I can say my n over here, and this is just a minute, I'll just write it as n over here. Okay, so now we are trying to what I can say write the this one. This is what is the formula, and your n might vary. That is your 4-point DFT. For 4-point DFT it is 4. For 5-point DFT it is 5, and for 8-point DFT it is 8. Right? Yes. So now this is what is my matrix method. These two formula works on. What you're supposed to do is you're going to what I can say write this formula first for matrix method, then you're going to write what is your x of n. I'm so sorry, I haven't written equals, please do oblige. So you're going to write omega of n, so that is you're going to write what is your omega of n matrix, where what you are supposed to write is you're going to write first this formula. So the formula is given by, you're going to write like this, and then after that you're going to write where your omega n matrix is equal to, that is you're going to write that particular matrix, and then you're going to write your x of n matrix that is being given in your question. This is what is that you get in your question, right? Yes, that you're going to write, and then you're going to write substituting all this in this particular equation number 1. So we get it as, and you're going to write and then substitute it and then do the process, right? Yes, that is what how we write for our exams, and even the same for the IDFT also, right? Yes. And your second one we learnt is with respect to what? The formula method. Right? Formula method has not been asked much, but try to study, because as you're from 4-point DFT only you're getting the question. Try to study all the methodology from 4-point DFT, right? So, and we are also not leaving 8-point DFT students. We are also going to do that, so that if we might ask, we don't know, we are not sure, but if we might ask, so then we have to work it out, right? So that is why I am going to work it out that also without pay, so that it would help you if it comes for exam, right? At most it is 4-point DFT only, but let's also learn that without fail, right? Yes. And formula method, you have to use a formula called as x of k is equal to what I can say the summation of n minus 1 to n is equal to 0. Just a minute, I'm so sorry. that is summation of n minus 1 to n is equal to 0, which is equal to what I can say, the x of n into e to the power of minus j 2 pi 2 pi by n into kn, right? Yes. So this is what is your formula for what I can say, the formula method, that is DFT. So for IDFT there is a different formula. Let's write that. Okay. So for DFT this is what is the formula, and you are going to write this formula, and according to this formula you are going to what I can say substitute. So here what you are supposed to do is you are going to substitute here what I can say, here your trick is your k value is equal to what I can say is 0, the k value is constant, and your n value varies. Your n value varies from 0, 1, 2, 3, right? Yes. So k is constant, n varies, right? Yes. You can see in any of the question that comes, your k is the constant, and what happens, your n value gets varies, right? But in the case of IDFT methodology, what is in the case of IDFT methodology? So in the case of IDFT methodology, what is that going to happen is that, so you have to use another formula called as what? That is, just a minute, I'll just push it up. Yes, it's enough. So for my IDFT, it is x of n is equal to what I can say, the summation of, that is n minus 1 to what I can say, the what is your formula? Your formula is equal to, that is your summation of n minus 1 to what I can say, the k is equal to 0. Just a minute, I'll write the formula. Please do wait for a second, students. Yes, I'm so sorry for the distraction. Okay, n minus 1 to k is equal to 0. That is your 1 by n has to be written outside, right? 1 by n into, that is your what I can say, your x of k into e to the power of minus j 2 pi by n into kn, right? Yes. So here there is one standard formula, students. What is the standard formula for this particular IDFT is that, so what you're supposed to do is, here you know that your n is your constant value and k varies, right? For all the what I can say, the particular values of n, your k varies, right? So that is why what I'm planning to do is, I'm going to have a formula called as 1 by n into what I can say, my your x of k. Just a minute, students. I'm so sorry. Please do oblige for this. Fine. Yes. And this is x of what I can say 0 into e to the power of minus j 2 pi. This is 0, students. Yes, this is 0 because first I am substituting my n is equal to 0, right? First I am substituting my n is equal to 0. What I am supposed to do is, I am going to substitute what I can say, all the values of k, and I am going to keep n as it is, right? Here I don't keep n as it is because if anything multiplied by 0 is obviously 0, that is why. So I once again take it as plus, that is my x of 1 into e to the power of, that is what I can say, minus j 2 pi by n into n, because the k is 1, and plus x of 2 into, that is just a minute, students, I'll write it in a proper manner. Plus, that is x of 2 into e to the power of what I can say, that is minus j 2 pi. Just a minute, I'll just push this. Okay. Minus j 2 pi by what I can say, the n into what? The n into 2n, right? 2n and here it is plus x of 3 into, like this you are going to write your formula. How you have to write it? You are going to substitute all the values of k, that is 0, 1, 2, 3, and you are going to keep n as it is. And you are going to use this simple formula, and according to this formula you are going to substitute very first n is equal to 0, and you have to, what, after writing this formula supposed to write substitute n is equal to 0, and you are going to substitute wherever n is present you are going to substitute 0, and after you substitute 0 then you are supposed to get the resultant, right? And once again you are going to use the same formula, right? Substitute n is equal to 1, and for n is equal to 1 you are going to get the resultant, and then once again you are going to substitute n is equal to 2, I'm so sorry, n is equal to 2 and get the resultant, and once again you are going to substitute n is equal to 3 and get the resultant. This is what is the process, right? Here k is various and n is constant, right? Yes, please do understand this. If you don't understand this only, then you will fail, right? Yes, because many people will vary n and will keep k as constant over here. It is not, right? Your n value will be the constant, and for that constant value of n your k varies, right? That is why. So why we have taken this formula is because for all the values of n as your k is varying, right? For all the values of n as your k is, where k variation is the same. For n is equal to 0 your k varies from 0, 1, 2, 3. Just a minute, I'm so sorry. For values of, for n is equal to 0 also your k varies from 0, 1, 2, 3. For what I can say here, what I can say here, n is equal to 1. For n is equal to 1, what is that going to happen is your k varies from 0, 1, 2, 3. For your n is equal to 2 also your k varies from 0, 1, 2, 3, and for n is equal to 3 also your k varies from 0, 1, 2, 3. That is why what is that you are going to do is, for that you are going to write the same very simple formula, right? Your k here is varying from 0, 1, 2, 3, and your n is constant, so for n you are going to substitute 0, 1, 2, 3, right? Yes. For this also it is k is constant and n varies. For this you are going to write the formula, and according to this formula what is supposed to do, you are going to write it as, put k is equal to, what I can say, 0, right? Put k is equal to 0 and your n is equal to 0. Put k is equal to 1 and what I can put k is equal to 0 first. Put k is equal to 0 because your k is constant, and put n is equal to 0, 1, 2, 3. Put k is equal to 1 and n is equal to 0, 1, 2, 3. Right? That is what you are supposed to do. Right? Yes. Okay, like that you are going to do, write it and just solve it. So I am going to, what I am supposed to do is I am going to just write it in a sheet of paper, and I am going to share it to you so that you get to know how to represent this particular for examination, right? This is what is my second method, what is that called as my formula method. And the third one, is here, what I can say, the concentric circle method. Okay. So for your concentric circle method, what you're supposed to do is that, so you have a formula for concentric circle method. So what is the formula for the concentric circle method? So that formula for your concentric circle method is that it is your, what I can say, just a minute students, I'm so sorry, I'm so sorry, just a minute, wait for a minute, really sorry. So you have a formula for your concentric circle method, that is your x3 of m is equal to x3 of m is equal to what? That is summation of, what I can say, or you can write it as xn of m. This is n because you can, it is the value that we are taking. Xn of m is equal to, that is summation of n is equal to 0 to 3. N is equal to 0 to, that is you can write it as n minus 1 here. I am taking it for one problem, but that is not. Just let's take the general equation, right? N minus 1, that is, n minus 1, that is what? You can write it as that is x1 of n into x2 of m minus n of 4. That is x1 of what I can say the n into x2 of x2 of what I can say here m minus n of 4. That is what I can say m varies from 0, 1, 2, 3. Right? Yes. Here m varies from 0, 1, 2, 3. No need of substituting the value of n over here. What is supposed to substitute is you're only supposed to substitute the value of an m wherein the m varies from 0, 1, 2, 3. Right? Very first you're going to substitute the value of m, and if you're going to substitute the value of m, what I can tell is that here let me write it as capital N. I'm so sorry. Yes. Let me substitute the value of m is equal to 0. If you substitute m is equal to 0, you're going to get your equation as, so why I'm writing this equation is because this is same for all the what I can say the concentric circle method with respect to 4-point DFT. So that is why I'm writing this, and this equation is also the same for all the 4-point DFT, right? Nothing changes, only your value changes. Here what happens is your sequence changes, that's all. I'm going to tell you this again. So it is n is equal to 0 to what I can say n minus 1, that is x1 of n. Just a minute. X1 of n into that is x2 of what I can say, you get it as m minus n. What is your m is equal to 0. So this is 0 minus n is what? It is minus n, right? So it is minus n of 4. So this is what is you get when you substitute m is equal to 0. If you are really confused with this, please do try to practice these 4 equations for m is equal to 0, 1, 2, 3. And what is that going to happen over here is that, so you have to what I can say very first keep your circle, that is your inside circle in clockwise direction. This is what in clockwise direction, I'm sorry, this is what in anti-clockwise direction. It is anti-clockwise direction, that is what in x1 of n sequence. So I'm going to keep it in anti-clockwise direction, right? And then what is supposed to do for x of 2 minus n, so what you're supposed to do is you're going to keep this particular in clockwise direction, right? Yes. Just a minute. I've written all this and provided it to you once already in the YouTube, so you can check with that photo that have been released on YouTube, right? You will get to know. Okay. And here for m is equal to 1. Okay. So which is equal to what I can say the summation of n is equal to 0 to once again your n minus 1. That is your x1 of n into that is x2 of what I can say. Just a minute students, really sorry for the distractions. X2 of that is 1 minus n whole to the power 1 minus n of 4. So for this what I have to do is, just a minute, I'm really sorry. For this what you're supposed to do is you have a what I can say that is your anti-clockwise students, that is anti-clockwise to one position. Which one? This is minus n of 4. You're going to shift it to anti-clockwise in one position, right? Just a minute. Anti-clockwise direction and one position, that is whatever the x2 of minus n of 4, whatever you have, what I can say written in clockwise direction, that thing you are going to shift it in anti-clockwise direction to one position, right? Let me write the equation for m is equal to 2. If I write the equation for m is equal to 2, this is the same for all the problems. So that is why please to try to learn. So this is what is also one of the important thing, because so this is a procedure oriented, and whatever the procedure that you follow, the same procedure you follow for other problem also, but the numericals change. For this particular, the sequence will change. You are going to write the circle. I told you this first one is anti-clockwise and this is clockwise, right? Just a minute, I'm so sorry. This is clockwise, right? And for this particular, your circle is one is both are anti-clockwise, right? This is also anti-clockwise circle. This is also anti-clockwise circle, right? This is the both are same, okay? And for this particular one, so here your sequence changes. For us, we have got 2 1 2 1 and 1 2 3 4. For you, you might get a different sequence. Till here, you're supposed to do. What you're supposed to do, you're going to write this formula. I'm going to write the two sequence and you have to write the two sequence, and you have to write what is your x3 of m. So x3 of m will become equal to, so you're going to first write the two sequences. Given two sequences are x1 of n and x2 of n, then you're going to write that sequence. After writing that, you're going to write to find x3 of m. So question mark. So x3 of m is equal to, you're going to write this formula. So this is a general formula. For you it is x3 of m, because you're only learning for 4-point DFT, right? 8-point DFT also you're going to learn, but for your exams 4-point DFT is the most important. So try to learn that. So you're going to write this equation. After writing this equation, you're going to first substitute m is equal to 0. You have to write first substituting m is equal to 0, and then you're going to write all this and all this equation, and you're going to substitute your m is equal to 0 when you get minus n of 4. Then you're going to write this one circle in anti-clockwise direction and the other circle in clockwise direction. This one in anti-clockwise. x1 of n is anti-clockwise. So here one more thing is that your x1 of n circle should be inside. This circle is x1 of n, and outside this x1 of n circle, your x2 of minus n of 4 circle should be present, right? x2 circle should be outside, x1 circle should be inside, right? Yes. So after this, you're going to write this particular circle, and this is in clockwise direction, and after you write all this, your sequence will change. For me it was 2 1 2 1 1 2 3 4, but for you it might be different. So whatever your x1 of 0, x1 of 1, x1 of 2 and x1 of 3, and whatever your x2 of 0, x2 of 1, x2 of 2 and x2 of 3 is given to you, that one you are going to substitute. That's it, nothing else. This all whatever I have written from here till this is the same. But when you write this circle for each and everything, for m is equal to 0, if you construct a circle, for m is equal to 1, if you construct a circle, so after you are going to mention your points, that is your x1 of 0 to x1 of 3 and x2 of 0 to x2 of 3, then you are going to write the values that is being given to you. According to the values or the sequence that is given to you in the question, you are going to write it. That's all. Only that sequence will vary. All the others are same, right? For here it is equal to, that is what I am trying to tell you. Please to understand and please to work out all this which is really important for exams, and it is helpful for you students, right? I am making things which are really helpful for you. I am not just blindly doing things over here, right? Yes, this is x1 of n into x2 of, just a minute, I don't know why it is becoming too slow. Wait a second, I'm so sorry. x2 of what I can say, that is 2 minus n, right? Yes, of 4. So this both are anti-clockwise, and if you come to m is equal to 3, it is what I can say here, this one, that is n minus 1 to n is equal to 0. The same thing you are going to write, that is x1 of, that is x1 of n into what I can say, the x2 of your, what I can say, 3 minus n, right? 3 minus n of 4, right? This is what is the same. If you write this equation and then plot a circle, after plotting the circle, you mark x1 of 0 to x1 of 3 position and x2 of 0 to x2 of 3 position in the circle. After marking that positions, you need to see through what is the sequence that is given to you, the values inside the sequence, and then substitute that values there. That will only change. All others are same, right? This is what is with respect to your concentric circle method. I guess I've told you everything and I've shared a photo on it also. Please do see that. And my last methodology we learned is DFT and IDFT methodology that we did it yesterday. Just a small what I can say revision of this because we have done it yesterday or day before, I guess. Yes, so yesterday we did not do any what I can say the videos with respect to this particular we are doing it today, so we did it day before. Okay, yes. So DFT and IDFT methodology is nothing, the same formula that we wrote it before for with respect to matrix method, that only you are going to use, and you are going to get your x3 of k, x of 3, that is x of 3 is equal to what, that is here what I can say x of 1 into x of 2. No, just a minute, I am going to tell you this. So here you do DFT and IDFT method for what, for that particular formula. Which formula? That is here what I can say here, x of 4 is equal to omega 4 into what I can say the x of 4, right? Yes. And that formula, one more thing, which formula, this x of 4 is equal to, that is what I can say 1 by 4 into this omega of 4 into what I can say the, what I can say here, x of this one, right? Your x of 4. So you're going to substitute for this particular these two formulas, and what you're supposed to do is, very first thing you're going to use this formula and substitute for the given sequence, that is x1 of n into x2 of n, right? There are two sequences that is given to you, and for those two sequences you are going to substitute the values. After you substitute the what I can say, after you do the what I can say DFT procedure, after you use this formula for this x1 of n as well as x2 of n, then you are going to what I can say multiply. What you have to multiply? So you have to multiply, that is here what I can say the that is what I can say, that is your x3 of k. You have to get x3 of k. What is your x3 of k? Your x3 of k is equal to x1 of k into x2 of k. So your two sequences given are x1 of n and x2 of n. So for that you are going to find out, that is your x1 of k. For x1 of n you are going to find x1 of k by using this formula. For x2 of n you are going to find x2 of k by using this formula, and whatever the resultant that you get for x1 of k and x2 of k, that you are going to multiply to get x3 of k. So this is what is you do in DFT method. In DFT method you are going to find x1 of k and x2 of k for the given sequence, x1 of n and x2 of n, and then you are going to get the x3 of k resultant, that is the multiplication of x1 of k and x2 of k, right? Then after that what is supposed to do is you are going to use this formula. So for this formula, you know what is this x4, right? That is this x3 of k resultant. Here you are going to multiply, and this omega 4 matrix is with respect to your IDFT. IDFT matrix you are going to write, and here this x of 4 is nothing but the x3 of k. Your x of 4 is nothing but the x3 of k that you have got, and that x3 of k you are going to substitute, and you are going to multiply that omega 4 matrix with respect to IDFT and the x3 of k resultant, and then you're going to divide it by 4, and then you get the original resultant, right? Then you get the original resultant, that is original resultant what you have got with respect to the concentric circle method, you know, the same result you get. That is why I took the same problem and I solved it, right? The original resultant you are going to get it as, right? Yes. So now this is what is for what I can say the revision class, okay? And concentric circle method, this is all circular convolution methodologies. I have to write it over here. This is circular finding out a circular convolution, as here this was also including 4-point DFT, so I did it. So this is circular convolution methodology, and this is really important, right? Yes, really important. And so why we are making use of this DFT and IDFT is because whatever you got the resultant in concentric circle method, so the same resultant you are going to get it in DFT and IDFT method. That is why DFT and IDFT method and concentric circle methods have two sequence. If you do in any of the method also, if you do in both the method also, resultant will be the same, right? Yes. So this is what is for today's revision session, and let us, what I can say, move on to one problem with respect to IDFT, right? Just a simple brief on that particular problem. So here it is. My question has been given by that is your x of k is equal to what I can say, the 10, your minus 2 plus 2j, and what I can say minus 2. And what is the question, students? Just a minute. Minus 2 minus 2j, right? Yes. Okay. So here what is supposed to do? The same formula. What I told you, that is 1 by n into what you need. You need x of n, right? So the same formula is supposed to use, and I'm going to just tell you how to do it because we have done one problem. So this is 1 by n into, that is here what I can say, x of 0 into e to the power of 0. Please to try to first write the IDFT formula, that is original IDFT formula that you have already known, and after writing that formula only you are going to write this, right? Yes, it is x of 1 into what I can say, the e to the power of, just a minute students, I'm really sorry. Wait a second. Just a minute. That is e to the power of what I can say, minus j 2 pi by n, minus j 2 pi by n into k, that is what I can say, plus x of 2 into, just a minute, wait for a minute students, I'm so sorry. Okay, yeah. That is plus x of 2 into, that is e to the power of minus j, that is 2 pi by, okay, and here it is plus what I can say, the this one, which one? Yes, just a minute, that is x of 3 into, it is 3k, right? It is 3k, and yes, so now here you can see that so that is equal to this formula, and after this formula you're going to substitute like this. How you substitute? You're going to substitute here n is equal to 0, and if you substitute here n is equal to 0, here n becomes equal to 4, and here what is happening is it is e to the power of this here you're going to substitute. Just a minute students, I'm so sorry for this, please do oblige. I did not see while writing, I'm really sorry. Here it is what I can say, here n, because your k is varying and n is constant, so I'm going to substitute here n is equal to what I can say, the 0, right? Yes, and you can do the same for a DFT also. What happens to your DFT is that you're going to, instead of this 1 by n, you'll having all this, but instead of n you're going to write it as k, right? For your DFT, what happens is that, so you have to cancel this, so this is not required, so this 1 by n is not required for a DFT, and instead of n here you are going to write it as k, because you have varied the values of n and your k is constant. So here we are going to keep the k over here instead of n, and you are going to, what I can say, substitute the values of different values of k, and then you are going to get the resultant, right? Yes, if you substitute n is equal to 0, so what you are going to get it as? So you are going to get it as, that is your, what I can say, your 1 by 4 into that is here, what I can say here, 1 by 4 into, that is, this is x of 0. What is your x of 0? 10 into, what I can say, that is your e to the power of 0 is 10. E to the power of 0 is 1. So therefore it will become 10. So 10 into 1 is 10. And here it is, what I can say here, that is plus. So that is equal to x of 1 is what? So x of 1 is equal to, that is minus 2 plus 2j. Why all this is the same? Because you are substituting your k is equal to 0, and if you substitute your k is equal to 0, your n is equal to 0, so then you are going to get it as e to the power of 0, which is equal to 1 for all. So that is why your resultant will be the same, that is plus of minus 2, that is plus of minus 2 minus 2j. Just a minute. Okay, so now if you simplify, you get the value as 1. That is, I can't show the simplification due to my calculator issues. So this is a minus 2 plus 2j. All this you have to put in calculator like this only without fail. No need of putting it separately. Please to put all this together directly in the calculator. Whatever you get the resultant, you divide it by 4. That's it. Right? So now if I consider my n is equal to 1. If I consider my n is equal to 1, so I get it as 1 by 4 into 10 once again, right? My 10 once again, right? Because it is e to the power of 0 directly, because your n is equal to 0 and k, what I can say, your k is equal to, what I can say, 1 and n is equal to 0, right? That is fine. And here it is plus, what I can say, you have got it as, that is equal to your minus 2 plus 2j into, what I can say, your j. How your j is, what you're supposed to do is, here there is one trick you have to do, that is you do this, right? For your n is equal to 1, you substitute x of 1 into e to the power of minus j 2 pi by n into 2 pi by 4 into, what I can say, here 1. You substitute like that, and then what you're supposed to do is, you are going to write directly as j. So what you need to know is that, here if you substitute your 1 over here, so what you're supposed to do, these values will be j, this value will be minus 1, and this value will be, what I can say, j. For what? This value will be j for, what I can say, the very first value, that is for n is equal to 1. For n is equal to 1, you have to remember that this e to the power of minus j 2 pi by n, and n will be is equal to j for you. And for your this particular, that is e to the power of minus j 2 pi by n into 2n, it is minus 1, and e to the power of minus j 2 pi by n into 3n is once again minus j. You need to know all this. And for n is equal to 2, it would be minus 1. It would be, what I can say, here minus 1, 1 and minus 1, right? Yes. And for here, what I can say, once again, here n is equal to 3, it is what, here minus j, minus 1 and j, right? How we have to know that is that this particular, you need to understand that this particular e to the power of minus j 2 pi by n into n, for your n is equal to n is equal to 1, which is equal to what? It is equal to j. And how we need to know that is, how we need to learn that is, you have learned that, you learned this formula, right? In the same way you learn like that. What you need to do is, for your, what I can say, let me write it over here in a short manner. For your, what I can say, n is equal to 1, n is equal to 1. the e to the power of what I can say minus j 2 pi by n into what I can say the n, and e to the power of minus j 2 pi by n into 2n, and the same with respect to 3n's are, that is equal to your j minus 1 and minus j, right? That is what is you have to learn, right? And for the second one, you are going to multiply the resultant with what? You are going to multiply the resultant with, that is here minus 1, 1 and minus 1. For the third one, you are going to multiply with minus j, that is minus 1 and j. So here it is what I can say minus 2 into minus 1. Like that you are going to by heart it. You know what is a 4-point IDFT matrix, right? The same only it comes over here. See, these are all this j, this minus 1 and minus j, all were present in my 4-point IDFT matrix, right? That is what you get it over here, right? Yes. Don't try to substitute things and all in the calculator for this. Don't try to waste your time, right? Yes. That is what I can say minus 2j into minus j. You have to know what is the values of e to the power of minus j 2 pi by n into n, e to the power of minus j 2 pi by n in 2 pi by n into 2n, and e to the power of minus j 2 pi by n into 3n for your n is equal to 0, 1, for n is equal to 1, 2 and 3. What I am supposed to do is, right, for n is equal to 1. Okay, for n is equal to 2, for n is equal to 3, right? Right over here it is e to the power of what I can say minus j 2 pi by n into n, and e to the power of minus j what I can say 2 pi by n into 2n, and then e to the power of minus j 2 pi by n into what? It is minus j 2 pi by n into 3n. So for all this, for your n is equal to 1, what you are going to get a resultant values? You are going to get it as what? It is equal to j minus 1 and minus j, right? And here is your what? Here is your minus 1, 1 and minus 1, and what I can say here is your, that is equal to, just a minute students, I'm so sorry. Here is your value, that is equal to what I can say your minus j minus 1 and plus j. This thing you need to know. This table, if you know, you can do it easily, right? Whatever the value you're going to, you need to know this table. Just a minute, I'll just erase it. I have to put a line on the top. This table you need to know. If you know this table, you can easily crack your formula methodology without fail. So please try to know this table without fail. This table is very, very important. Okay, yes. So now here, let us move on to the original problem. So this, if you substitute in calculator, you are going to get it as 2, right? Yes. And now coming on to my next one. So that is why I am going to tell you, if you can't substitute in calculator all these things by substituting your values of n, capital N is equal to 4, and once again 2 into 2, and what I can say here once again your 3 into 2 and 3 into 3. If you find it really difficult, so please do what I can say, try to what I can say, just learn this without fail, right? You know what is your 4-point what I can say IDFT matrix. These values were present in 4-point IDFT matrix. All this value. The other side was 1 1 1 1, right? But if you leave 1 1 1 1 and 1 1 1 1, the 4 ones which was present on the what I can say in the horizontal as well as vertical, if you leave at the very first column, and what I can say the very first row and very first column. So you can just, what I can say, consider all these values which are present in my 4-point IDFT matrix. That only you are going to substitute. So that is why make a table like this and learn this, right? You have learned your 4-point IDFT matrix, and the same you are going to apply it over here. So these values you are going to get by substituting the values of capital N and small n over here. So try to learn this table without fail. And this table, if you learn it, and if you learn this formula, so then you will ease your exams without fail. These two you are going to compulsorily learn without fail, right? Yes. And now let me go on to what I can say, my x of 3. X is equal to, that is, I'll write the resultant now. Okay, so here it is 1 by 4 into 10 into, what I can say, it is 10 because e to the power of 0 is 1. Here it is plus minus 2 plus 2j into, what I can say, let me go to the table, and according to my table, so that is e to the power of minus j 2 pi by n into n for n is equal to 2. Right, here it is 2. I'm so sorry students, just a minute, I'll just make an change. I'm so sorry. So let me go back once again and just check it. Yeah, okay. For your n is equal to 2, here it is x of n. So for your n is equal to 2, it is what? So for your n is equal to 2, it is what? Your minus 1. Right? According to this table, it is minus 1. So let me substitute minus 1 over here. Right? Yes. And once again it is minus of minus 2, and once again here for your that is for your e to the power of minus j 2 pi by n into 2n, for n is equal to 2, it is 1. So let me substitute that as 1, because here you what I can say, here you are getting this values only. Here in place of this you have in the formula, that is e to the power of minus j 2 pi by n into n. Here you have e to the power of minus j 2 pi by n into 2n, and in the third one you have e to the power of minus j 2 pi by n into 3, and those values we are substituting. For it n is equal to 1, 2 and 3. That is why I wrote this table, right? And now here it is, what I can say, minus 2j into, here for e to the power of minus j, what I can say here, n by 3, n into 3 by n into 3n, for n is equal to 2 is minus 1. So I'll write it as minus 1 over here. Right, I'll write it as minus 1 over here, and my resultant would be is equal to 3. You got it? My resultant would be is equal to 3. Then, okay, so it's n is equal to 3. So now if I take my x of 3, so for my n is equal to 3, my x of 3 is equal to what? That is 1 by 4 into 10. What I can say, that is plus, or it is what I can say, this is 3, yeah, correct? Yes, okay, 3, yeah, this is okay. So here it is minus 2 plus 2j. Why I am telling you all this is because you know what is your 4-point IDFT. So if you substitute for capital N and small n over here, I'll come back to this. If you substitute, here it was what, e to the power of minus j, just a minute, I'll go back. See the formula. Here it is x of 1 into, see what is this x of 1? So this is x of 1 into e to the power of what? E to the power of minus j, what I can say here, 2 pi by n into n, right? You know that, right? Yes, you know that, right? Here you try to substitute your value of n as 4, and here you try to substitute the value of n. But if you try to do all those, so you get the resultant as 4-point IDFT matrix only, right? That if you substitute this only, you get the values that is present in 4-point IDFT matrix. That is why I am trying to tell you. So this formula only you are going to get. So what you are supposed to do for this, you are going to write this formula first, and you are going to write it for n is equal to 0, n is equal to 1 and n is equal to 2. For this particular e to the power of minus j 2 pi by n into n, what is the value for n is equal to 1? If you substitute n is equal to 1 here, what is the value? It is j. If you substitute n is equal to 2, what is the value? It is minus 1. If you substitute n is equal to 3, what is the value? Get it as minus j. So like that you are going to make this table, and if you write it, it will become so easier for you, right? It will become so easier for you. Try to write this table and try to learn this without fail. If you learn all this without fail, then it would be easier for you, more easier for you, right? Yes. Don't try to substitute the values of e to the power of minus j 2 pi by 4 into 1 and try to do that cos and j sin formula. Don't do that, because whatever you do for this, whatever the resultant that you get will be a value that is present in your what I can say IDFT matrix itself, right? IDFT omega 4 matrix itself. That is why I told you to learn that directly instead of doing all those in your examination, right? Don't try to substitute and don't try to take cos pi by 2 minus j sin pi by 2. Don't do all those. Just learn this table for that. That is why I'm trying to tell you. Just learn this table for that. So how to do is, when you write this formula first for n is equal to 0, then you're substituting. What you have to do is, very first you're going to write n is equal to 0. Here what you're supposed to do, for n you're going to substitute it 0, or let me take n is equal to 1 only, because for 0 it is always e to the power of 0 you get, right? Yes. And for n is equal to 1, if you substitute what, you write this formula. What you write? You write 1 by 4 into x of 0 into e to the power of 0 plus x of 1 into e to the power of minus j 2 pi by 4 into 1, and here it is e to the power of minus j 2 pi by 4 into 2, and here it is e to the power of minus j 2 pi by 4 into what I can say, the 3. If you write like that, then what you're supposed to do is you are going to directly write this particular. Which one? Directly write this particular. To directly write this particular, you need to learn this table without fail, right? That is why I am telling you. So instead of doing all those, applying your cos and j sin formula, try to learn this table directly. Okay, because these values in IDFT and the IDFT matrix, right? That only you are going to get. That is why try to learn this table without fail, right? I am repeatedly telling this because you need to, it should go into your head. That is why, right? And here it is once again. It is what? My value for e to the power of minus j 2 pi by n into n, for my n is equal to 3 is minus j. So let me substitute minus j over here, and it is plus, what I can say, plus of minus 2 into that is for e to the power of minus j 2 pi by n into 2n, for n is equal to 3. What is my value? It is minus 1. So let me substitute minus 1 over here, right? Yes. And it is once again plus, so that is a plus of minus, so sorry, write it here itself, minus what I can say, plus of minus, that is 2 minus 2j 2 minus 2j. So now for my e to the power of minus j 2 pi by n into 3n, for my n is equal to 3, the value is j. So let me substitute the value as j. So if I substitute the value as j, so therefore you are going to get a resultant as 4. So a total resultant, what is my x of n? I am really sorry. So that is what is my resultant here. X of n is equal to, here 1, 2, 3 and 4, right? So this is what is the resultant, and this is what is for today's session. Please try to learn that formula for IDFT and the table for IDFT, right? If you learn the table, it will be really easier for you. The values inside the tables are all that you have got in a 4-point IDFT matrix. So 4-point IDFT matrix, that is omega 4 star. If you see that, you have all the values there. In the second row, you have minus j, minus, you have j, what I can say, minus 1 and minus j. This value you have in the second row. this value have in the third row, this value have in the fourth row, right? Yes, that is what I'm telling you, right? So that is what you have to learn this table directly, and please do try to substitute, because your values are n is equal to 1 2 3 0 1 2 3 only. For your 0 you get e to the power of 0 everywhere, so this would be e to the power of, these 3 would be e to the power of 0 for your n is equal to 0. But for your n is equal to 1 2 and 3, you will all get the same, this particular same thing, and you're going to learn this, right? Yes, please do try to learn that without fail. This is what is for today's session, and in tomorrow's session we are going to start with 8-point DFT, and then we are going to do with n-point DFT, whichever possible. I'll start it. So I'll either start with n-point DFT or 8-point DFT. So let me see, because n-point DFT is really important. You have a questions from n-point DFT in your examination. After that, we are going to do with what I can say, the properties of DFT, which is really important, and whatever the properties that is mentioned for you in the syllabus, that only we are going to do. We are not going to do anything outside, right? Yes. And this is what is for today's session, and all the videos are of, we are going according to the examination, and we are going according to the important concept that is coming for exams, right? Please do watch those videos for fail, and thank you.